want to discuss uh, fundamentals of programming. All we need to do for this first uh, class in this series is to lay foundation for programming generally, because other series will come that will take different aspects of programming, will take different kind of problems and implement it using different programming languages. But again, to start with, let's understand what a program is and why it's programming, that good aspect of computing that we need to know. From some of my videos, especially the ones on business information technology, you will have seen where I explain about hardware and software, saying that software are the unseen component, the logical components of the computer that drives the activities of any computing device. So what is a program? In one word, a program is an instruction that is written in the language the computer can understand in order to perform a specific task. A programs are instructions or set of instructions, logical instructions that are written in the language the computer can understand in order to perform a specific task. Obviously, computer does not understand all languages. With time, you will understand the language the computer understands and how computer understand them. And it is in these languages that programmers who give instructions to computers, they communicate to computers in all these languages that the computer understands. Having laid that foundation, we will understand that instructions are very many. Now, from simple instructions to complex instructions. The same thing with software. We know that we have hundreds of thousands of applications that are written by programmer to achieve different things. Games. If you talk about games alone, there are hundreds of games. All these games are written using a specific programming language in mind. The Microsoft Office that we work with, our Microsoft Word, our Microsoft Excel, our Microsoft PowerPoint, are all programs that are written with a particular computer programming language. One basic component that we need to understand from foundation in talking about programming is problem solving. Problem solving. Because basically, the task that our program achieves is actually a problem that is solved. So it will be nice if we quickly run through what are the basic steps that is required in a bid to solve a problem. What are the basic steps that is required in a bid to solve a problem? Here I title it as sequential steps involved in solving problem. What are the sequential steps involved in solving problem? If you go to 2, 3, 4, 5 textbook, you can have them presented using different method, different in the sense that it does not exactly need to look like what I want to show on the screen, but it will not be far-fetched from it. It will not be far-fetched from it. The first step is to identify the problem. You must know what you want to do. You might not have a total understanding of how first, but at least you need to know what you want before you set out and say a computer should help you. So you want to write a program that you want to put on the computer to help you achieve an objective or solve a problem. So you must be able to identify what do I want to do. Do I want to add two marks together? Do I want a computer that or a program that will take a file from one location and drop it in another one? Just like I said earlier, some problems are simple. some are complex. Even the problems that seem complex, you break them into different phases. You break them into different smaller phases and you solve it from that smaller phases up. You weave it back together and you are able to attempt to a complex problem. We will take several examples, several case studies, and we will demonstrate it in class as our journey continue on the issue of writing computer programs. Having identified the problem, you cannot begin to look at the features of the problem, definition. Because one thing that programming does, if you have the right thinking into a program or a project before you start, it helps you to solve a whole lot of problems that might likely occur later on upfront. And again, most of these problems that we'll solve are problems that reoccur. So if it reoccurs and you have your thoughts well laid out, you've already solved several occurrences of that problem that will come in the future upfront. And that is why sometimes you see software developer, they stay in one or two industry. They try to understand everything that happens in the ecosystem of that industry. They themselves become a professional or study the practitioner so that they will be able to give them solutions that is fit into every aspect of that industry. And as other things come, if I thought they would need to make some changes, the changes will be minor. So talking about problem definition here, you check each component of that problem. Is it something that can be predictable, or does it mean this one just come like that, is different from others? When you have all those things, that means you've identified the problem and you have defined each component of the problem. Then there is what we call algorithm or flowchart. The two of them are different, though they do the same thing. Algorithm or flowchart. Now, what is an algorithm? An algorithm now involves a programmer to write step by step all the procedure it will take to solve the problem, the specific problem now, step by step. For instance, let me give us an example. I want to add any two numbers together. So I can now say the first number that I want to add, I call it A. The second number that I want to add, I call it B. The container that will hold the answer when the two numbers are added, I call it C. So I can say step 1, input first number. Whatever number you input goes to container A. Step 2, input second number. The second number you inputted go to container B. Step C, add whatever is in container A and container B together and put it in container C. And the next step will be display the value of container C. You can see that 5 simple steps that it takes to add just any two numbers. I can go further and I'll say these numbers, I want them to be decimal numbers. I want them to be integer numbers, meaning those numbers must have a point. They must have decimal. That is, after the whole number, it must also have point. Something like 3.65 is a decimal number. But if I say I want it to be integer, which means it should not have any decimal places. Now, if I'm doing that, that means immediately you put in the first number, I might need to put in a control to check whether that number is in the right format that I'm expecting. But don't let us go that complex now. I'm trying to explain what an algorithm is. Some of our subsequent classes will have examples of problems that we're going to have in class, and I'm going to show you the procedure of what the algorithm looks like. So algorithm, for the purpose of this session, take it as sequential steps that the programmer has carved out, has thought out, that it will need to follow to solve this specific problem. Now, when you are doing we're building up an algorithm, you will have what we call variables and constants. What is a variable and what is a constant? Now, anytime you will need a value in a programming instruction steps in the programming suite, and you have a particular figure that the value it will have all through that program is the same, that is an example of a constant. For instance, if you are finding area of a circle and you will need to find pi, pi is constant, 22/7. Now, but if you are finding the area of different shapes, the other parameters will be different or might be different. So because it might likely be different at every instances, it is called variable because it varies. It's called a variable. Now, either a constant or a variable, you can use a container to hold them. And for the purpose of this introductory class, let's look at that container. It could be letter A, it could be letter B, it could be letter C, it could be letter D, it could be any of the letter from A to Z, and sometimes it could be more. For instance, you can say use score, S-C-O-R-E, to score the marks that student gets. You can say use mark, M-A-R-K. Then it also has its own rules too, depending on the programming environment where you're working. There are some letters that you cannot use as a variable name or as a constant name. You cannot use it as a container to hold any value because it has special usage in that very particular programming environment. We'll be getting to know all this as we progress on our classes on programming. Now, what is a flowchart? A flowchart is doing the same thing like an algorithm is doing, but in this sense, a flowchart is using picture. A flowchart is using symbol. We call those symbols predefined symbols. Flowcharts are predefined symbol. What you are seeing on my screen is an example of a flowchart. Is an example of a flowchart. You can now see from this, you can see when this program starts, it gets user input, get length, get width, then it multiply length, width, and height, and it displays the result and it ends. This is a good example of a flowchart. Each of these symbols has what it does. Each of these symbols has what it does, and it must be used to represent exactly what it does. And that is why we refer to it as predefined symbol. For instance, the oval represents start and stop. And you can see start and end here, having the same type of symbol. If you use it as a start, an arrow comes out of it. And if you use it to end a procedure, an arrow goes into it. You will see where you have your input and output, that they are the same. This is the symbol that is used for input and output. And you can see a rectangle here that is used for processing. There are other flowcharting symbols that will also be explained with time. So this is an example of a flowchart. So you see, what the programmer has done here, he has identified what he wants to do, and he has been able to simplify the steps that will be required to get it done. He'll be able to simplify the step that will be required to get it done. All right. Having done our flowcharts or algorithm, as the case may be, the next thing is coding. Coding is where the real programming takes place. That is where you write the list of instructions in a specific selected language, because there are several languages. Then you get it across to the computer executes it and give you back your feedback, your answer, provided there is no error. The first and the most fundamental is the machine language. The machine language is zeros and ones. The machine language is zeros and ones. The machine language is the only language the computer understands. And any program written in any other language will first and foremost be translated to the machine language. And feedback is also taken from the machine language to the language where the user make use of in communicating his instructions to the computer. We have intermediaries, and that is middle level language. We have compilers. In those days, when you want to install a programming language on a computer, is the compiler you will install. The compiler then serves as an intermediary that takes your instruction in the language of any of that programming language, translate it back to computer in zeros and one, and take your feedback back and follow the same mechanism through. And we also have assemblers that help us to interpret assembly language to the computer. Most importantly is the high-level programming languages. Most importantly is the high-level programming languages. The high-level programming languages are basically divided into two: command-oriented programming languages, then object-oriented programming languages. Command-oriented programming languages and object-oriented programming languages. As we continue in our classes, we'll be knowing the difference between programming languages that are command-oriented and the ones that are object-oriented. You can see a good example of command-oriented programming language, BASIC. BASIC is an acronym for Beginner All-Purpose Symbolic Instruction Code. Beginners All-Purpose Symbolic Instruction Code. We have Fortran, is an acronym for Formula Translator. We have COBOL. COBOL is an acronym for Common Business-Oriented Language. And we have Pascal. We have quite a whole lot of other command-oriented programming languages. And now we have the object-oriented programming languages that are used to write different kind of application. You can use to write a web service. You can use to write a web application. You can use to write a standalone application. You can use to develop a website and do just anything. You can use to write a mobile application that runs on PDAs and on mobile devices. So we have Java, we have C#, we have Visual Basic, we have Visual C, we have Python as examples of object-oriented programming languages. Now, having selected any of these to write your program, you will test that your program. You are looking for error. You will check whether there is error. That's the first thing you do. And there are three major errors I want to talk about. The first is syntax error. What is a syntax? Every programming language has its own rules of how do you declare your variable, how do you do your computation, how do you take input, how do you give outputs. So if you follow these rules, then your program will be syntax error free. Each of the programming language had different ways of letting you know that there are X, Y, Z things you ought to have done that you have not done here. And as you begin to implement, you will see some of those examples. Now, so you check your program for syntax error and correct it. Even expert programmers might likely not write a program for the first time without having one or two errors. So it is part of common programming practice for us to encounter some errors when we write our programs. Now, and it's also ways by which young programmers get to grow and develop. And one thing about programming, it's consistency in doing it. It makes you more an expert, and there will be less of the errors that you can commit anytime you write the program. The next is logical error. What is the difference between a logical error and a syntax error? A syntax error would definitely throw you an exception. It will throw you an error when you run it, because the error contradicts the rules and the expectation of that very particular programming language. So to identify syntax error and correct it are usually not difficult. But logical error is very tempting and could be very tricky. How? You want to add two numbers together. You mistakenly put multiplication instead of adding. It will execute. You will have answer, but your answers are wrong because the operator, what you want to do is not what you put there. And what you put there too is right. The computer understands it, it can execute it, it will execute it. But that is not what you want within the frame of that very particular problem. So that's how trickish logical error can be. So how do you test logical error? You use various scenario to test your program and look at what the answer is looking like and look at the kind of responses and feedback is giving you. Test with different scenario. I can remember in my early days in programming, we wrote a program, the program was working, we were very happy, and we want to generate reports. And a much more senior person that has to look at the program then, he said, okay, let's generate report from 1st January till 30th of February. We put it and the team brought it out. And the man said, February didn't get to 30th. There should be something that does not allow that 30th of February to come as a parameter for you to generate your report. That is the place of experience in writing programs. So, and anyone that wants to become a very good programmer must practice it again and again using different scenarios. The last of the error type is runtime error. And may I say that errors in computing is called bug, B-U-G. So the attempt you take to trace to your program to identify any of these errors and correct them is what we refer to as debugging. The attempt you make to run through your program and identify any of these categories of error is what we call debugging. Runtime error. Some programs will run on your system. By the time they deploy them, they have issues. Why? Peradventure, there are certain files in certain folder that it relates with on your system. But when you are running it on another system, on another environment, it's not seeing any of those things. It's going to throw exception. It's going to throw an error. So when you do all this, you now test again. And that is why the testing is coming again. Having seen this, that your program is doing what it's supposed to do, you now go to the next step, which is documentation. What is documentation? Why do we need to document? The kind of effort mentally, time-wise, that it takes to run the program requires that anytime you go to that program again, you must be able to have an understanding of what you do. And you should be able to do it such a way that if another programmer goes there and he has a need, an ethical need to make adjustments, to correct one or two things, to add to it, it should be made easier by the level of documentation that you have there. Because documentation is one thing that will make your program to run, whether you put it there or not. But a good programming practice always requires that you put documentation so that even the program you wrote 10 years ago, by the time you are back, you understand why you use this variable in this place. You understand why I use this operator in this place. You understand what this one is doing here. And it makes it easier for you to adjust and improve on the program. Then the next one is a user documentation. That basically is talking about manual. We're all used to that. That basically is talking about manual, talking about when other people want to use your software or program you have written rather, there must be step-by-step manual that guide them on how to use it. Each menu, each icon, what does it do, should be able to guide them so that they can become better users, because that is actually the essence of writing the application. Then the next thing and the last I want to mention here is versioning. Versioning is a way of looking at the program you have written and look at what has changed What has changed in the world of work? What has changed in the industry? What are the things we need to add? Can we hype it up a little and you change one or two things, you release it as another version or another edition? And that's what I mean by versioning. So this marks the end of our short session and understanding computer program, that is computer programming fundamentals. This marks our last session, and more other videos will be uploaded that will be a build-up on what we have learned today. Thank you for watching. Please watch, share, and let anybody that would need it get it, and like the YouTube page and also subscribe to the YouTube page. Thank you so much. Thank you.